I want to take a quick second and just talk about connections. Whenever I have a post to plate type of connection in an outdoor environment like this, I always opt for a carriage bolt. There's multiple different ways of doing this. You can use brackets, you can use bracing, you can use strapping, etc., etc. You can use lag bolts. The carriage bolt wins out in my mind because this stuff always shrinks, always shrinks. At least here in Canada, it is always delivered in a very wet state. And inevitably, once the end of next summer has come around, this is going to shrunk enough that there's going to be slack to be taken up. And it's easy to do that with a carriage bolt. The reason I like a carriage bolt over a lag bolt is that a carriage bolt can really exert another level higher of clamping force without fear of stripping out the threads in the wood. Secondly, if you do strip it out, the only time it's ever happened, or whenever it has happened, it's always been the nut. The bolt itself has been fine for whatever reason, and it's very easy to put another nut on. But usually the only time that's happened is when I've been assembling pieces with air impact, and they get something like 500 foot-pounds of torque or whatever those guns put out. So, but usually that's not a concern. So we're going to drill a couple holes and start fixing these permanently in place. And then we don't have to worry about any of this moving. Then our platform, we know, is plumb, it is level, and we can build off of this. We can take our jack out of the way and we'll be good to carry on. My machine of choice when drilling anything more than a standard hole, or if there's multiple larger holes or depth holes to be done, is the ubiquitous Milwaukee hole hog. These things are incredibly tough. You see them all over the place, and there really is no real good replacement for this. Battery power is great if you got a couple to do or whatnot, but you know, I'm never sorry that I've taken the extra time to pull this out and plug it in versus battery power. We're going to talk a little about bits. We have three classes of bits for this type of application. We have a modified spade bit, and I should mention that all three of these types of bits, you'll notice they have a screw feed tip to them, and that does a lot of work for you. That pulls the bit into the piece. So the first we have is a modified spade bit. This particular one is a Daredevil. They're not particularly strong, but they are cheap and they are effective. You'll see in this example here what's happened to the shank, and that's when I used this bit in the hole hog and I hit a big knot, and it just sort of comes with the territory. But to the credit of this Daredevil bit, it didn't break. It twisted, and I was able to back it out, redo it, and it finished the job for me this way. So now it hangs up on my wall, but something to be said still for these bits. The next line up is going into a triple flute auger. It can be a bi-flute or triple flute or whatnot, but it's a short auger. This is made by Irwin. It's called their speed bore line, and these are good bits. They are relatively cheap, and because of the geometry on the end here, they're very easy to resharpen. So I like to use these bits anywhere that I'm going to be worried I'm going to hit a nail, or especially a screw. Screw is murder on drill bits. It's just such a hard steel, and a screw, it can really rip them apart. So you can see how there's the flat geometry. Now let's compare that with a more traditional auger bit. You see the geometry is different. And so I found it's much easier to repair one of these, and these bits are also much cheaper if something does go wrong. So if you have to chuck it, it's not the end of the world. So where this may be a $5 bit, this may be a $8 or $9 bit, then we move up into something that's about a $30 bit. And it's a long fluted auger. These are indispensable. They are great. They are also really handy. You'll see electricians using longer bits like this a lot because they are drilling up top. They're drilling in floor joists and ceiling joists holes for wires and whatnot, and it's really nice to not have to be moving a ladder all the time. A longer bit like this, they can reach and put holes through without stopping and moving a ladder all the time. In other applications like ours, this long flute is very important because this long flute continues to evacuate chips as the bit goes in. And a shorter flute bit like this, as soon as you have gone past the flute, that depth, the bits will stop evacuating and they will start to compact. So you then have to pull it out and continue to go in. Now, because they have threaded pilots on them, pulling it out is not simply just pulling it out. It's sticking it reverse, backing it off a bit, pulling it out, and then going forward again. This does add time. So a longer full flute bit like this is indispensable. And usually the only time I don't use these is when I am worried about hitting screws. Or if there's a nail's usually not too bad on them. But I sort of save these for the cleaner wood a little bit. This particular one needs to be sharpened. You can see there's a bit of carnage to that front cutting edge. And so after this job, that'll go in the shop and get sharpened up. One last point I wanted to make about going with a full-length auger versus the speed bore is you can automatically see there's a huge strength advantage with the full auger. It doesn't neck down. It is not made to fit into an impact receiving chuck. And because of that, it is infinitely stronger. So when you start getting into larger diameter bits, an inch plus, an inch and a quarter like this case, it's almost, I don't want to say you can't use these, because I have, but you have to be careful with them, especially if you're putting them on a larger drill. You may have noticed that I actually put these on a little bit of an angle. I still centered them here on the post, so they look good. But they're on a little bit of an angle. That's just helping me miss the nails that have gone in. And it's also getting this a little bit further away. The end of this bolt's gonna be a little bit further away. A little bit easier to slip in a washer and not, without running into interference problems with hitting this front rim board. You may have noticed earlier that there was one piece in our bundle that was longer than the rest. Our bundle is composed of 10s and 8-footers, except for this one 12-footer. And it has an important role. It's going to be a cross brace. It's going to go from these two front railing posts. These two posts are probably some of the most important parts of this whole build, aesthetically and structurally, but especially aesthetically, because the railings are going to have to be straight and true relative to these posts. You can't have something that's off a little bit and then correct it. You will see that. On a railing, you'll see it every time. So it's really important, take the time, get these right, and we throw a brace on, then we know they're not going to move. So just to clarify, what I was trying to say here is that if during the construction process these posts moved out of plumb and we continued to work and then I didn't notice it, and the other posts downstream of on the railing were remaining in plumb, that it'd be quite noticeable, and after the fact it'd be quite hard to correct that. Alright, talking plans here. This is where plans really pay off. Now I know from my stair design that I'm going with an 1.25 inch nosing, and from the the nosing, coming back to filling this decking here, is staying. It's fine. It looks a little less than new, but structurally it's fine. And so on my plans here, I've figured out the math of the spacing, and that's how I came out with having a extension that was 21¼ inches. That allows me to use 2x6s without ripping any funny thing down, and having like a 3-inch board. No one wants to see a little thin strip just to sort of fill the gap. So yeah, so the first thing we're going to do is we'll place our front board, and that's going to establish our nosing. And it's very important that that stays congruent with the rest of the stairs, and that'll prevent any tripping hazards. And then what we'll do is we'll backfill in. And yeah, it's not, maybe, I don't know if it's the best way or whatnot, but it's the way I do it, and it works out okay for me. Believe how heavy these things are. All right. Make sure it fits before we go greening all the ends. This spacing is going to look pretty tight right now, but we're only leaving about a 1/16 or so. I know from experience that these boards are going to shrink almost a 1/4 inch each, and if we space them out a 1/4 inch now, we'll be sorry later. were doing a deck once, and the layout was a little bit tricky. It wasn't straightforward. And I got everything all hunky-dory and left for the weekend. And I just had the boards just tacked a bit. And on a hot weekend when I came back, those boards were about as straight as a whale's back. They were all over the place. And so I've kind of learned from that sense that the straightest they're going to be is when they're coming out of that lift. So we'll get them nailed down now, and you just avoid some problems down the road. Here we go, 6, 9.5. Okay, the pavers are almost perfectly square to the house. That's wonderful. But the elevation matches this concrete. This concrete is all wonky. And by wonky, I mean genuinely cattywampus. See where we're at here. We've got her set there. We're at 1 1/8. Ay caramba. Up 7/8 here. Wow, 1.5 inches. It's only 3/8 of an inch high here. So that's 1.5. Okay. So in this case, what we're going to have to do is we're going to have to leave a little bit extra. We're going to cut our stringers accordingly. We leave a little extra in the bottom. We're going to make sure then that we trim up to each one. And this is a little bit of a pain, but deviation is so much on here that if we don't do it, it's just not going to come out right. So yeah, that's the way the cookie crumbles. Chalk. Hold your chops. Okay, back up. There you go. Here I'm just using a basic 3-4-5 triangle to establish the first stringer. Make sure that the layout of it is square and that the subsequent measurements I take off of it for the other stringers also come out square. Finn, in the meantime, is keeping a close eye on me. He usually double checks my math for me. I think he's the real brains behind the operation. after I lay out everything from this point down to the last riser, I can then make a compensation on each stringer for the elevation difference. So the compromise that we're going to have is that in some areas it's going to be a slightly different height from ground to top of the first tread, but it's still going to be a square and level stair, and that's more important. I do not want to follow what's going on with this ground here. We're an 1 1/8 here, 1.5 inches high here, only 3/8 there, end up with a stair that's all wonky.
The last thing I want to do before packing up for the day is to establish where on the ground each stair stringer is going to land, and then I'm marking this location with a waterproof crayon. That way, regardless of whatever the weather does over the next couple days, when I come back on Monday, all our hard work will still be there, regardless of what the weather decides to do. So thanks for joining Finn and I on another day. Next time we'll be getting into the stair construction. Take care.